Hey everybody, and welcome back to the channel. This is Mark with Midwest Astro coming to you today to do a special on Nina's Advanced Sequencer. Now, last time, if you watched the first video, we went over just some of the basics of how to configure your setups and make sure that you have everything the way you would like it, and then to make sure that it matches your actual camera's specs and your telescope specs. But today, we're going to look at the Advanced Sequencer. Now, many people have expressed to me that, wow, this looks too complicated, and you know what? I thought the exact same thing. But after playing with it and learning what can be done and how it is to be done, I've really sat back and said, wow, this is so much easier than I realized. So today I want to try to share that with you. So again, we did the simple sequence last time, and today we're going to do the advanced. So the first thing that we want to do is think about how the sequencer is built. So if I come over here to the sequencer page, and then I go to the advanced sequencer option, which I'm already there. So now, what I highly recommend is over on the right hand side, read through all of your options and see what's actually available. As you can see, you can scroll through and there's a ton of available options for you. Now, the question is how do I integrate all of these things with my setup? So the first recommendation I'm going to make is look over here. We have category titles. So camera. Well, I know I'm going to have a camera connected, so I'm going to leave this open because I'm likely going to use some of these options. I do not have a dome, so I'm going to minimize that because I can't use anything with a dome. I personally do have a flat device, but I'm going to minimize it because a significant amount of people just simply don't. The focuser, I do use that as well, and I did forget to mention, but I do use a filter wheel because I use a monochrome camera. So we'll leave those expanded. Ground station, we'll get a little bit on that later, but I'm going to go ahead and minimize it for now. A guider, we are going to use PHD2 guiding, so I will leave this open. We're going to scroll down a little bit further here, and we're going to look, and we're going to see that we have loop conditions. Now, these will come into play when we want to loop in particular scenarios. Polar alignment, we're not going to actually worry about that in this particular setup, so I'm going to go ahead and close it. We're going to operate under the assumption that polar alignment was done manually all the way through. And even with this option, you still have to manually do it. It's just, it'll build it into your plan. The rotator, I don't use a rotator. Maybe you want to by doing a manual rotation. I'm going to forget it on this particular one. We're just going to assume the rotation we have is what we're going to go with. Safety monitor, I don't even know what that is. So I'm going to close that because I know I don't use it. And switch, same thing. We'll close that down. Telescope, we know we're going to have a telescope mount. It is maybe mislabeled. It should probably be mount as opposed to telescope. As we scroll down, we have utility, and we have some options down here as well. So one of the key things to look at as I scroll all the way back up to the top here is we have three options with this instruction set drop down. We have a sequence for objects. We then have a parallel instruction set, which, if you look closely, is indicated with the squares that almost looks like an upside down trident. That way, what we're going to do is we're going to run multiple commands at the exact same time. But if we go down to the very next one, you'll see that the squares are actually stacked one after the other for sequential instruction sets. So that's going to be more appropriate for taking images with a specific filter. We'll finish that filter and then we'll go on to the next object, right? We want things to complete in a specific order, and that's when we'll use this set. And then we know it's an instruction set because it's got this little box here. If it's open like you see here, that means, let me just drag it over and show you, that means we can see all the details, but if I click it, you'll notice the box closes, so we can minimize these instruction sets. So what I'm going to do is use a reference with Microsoft Excel. For any of you that have used it and built formulas, you know that you don't just build one massive formula from the beginning. You're likely going to build one formula and make sure it's what you want. And then you're going to add another formula to the bar, and you'll continue to build one large formula based off of building little segments at a time and testing to make sure that it's still working the way that you want to. We're going to do something that is actually incredibly similar today. We know we are going to take pictures. We know we need to unpark the scope. We know we need to check for meridian flip. We know all of these things that we need to do. So we're going to start at the very base. We are going to think about how do we want to image. So the first thing that I'm going to do here is I'm going to add a sequential instruction set. So you will see here that we have triggers, loop conditions, and instructions. Now, I personally do not like the word triggers. For me, the word trigger suggests this happens and then something else happens. But for Nina, I feel like it needs to be check criteria or checks something to that effect. And the reason being is because it's going to be criteria that we check for. And if something fails or meets the criteria, then it will do something else. So I understand why it's called triggers, but I think checks would be a more appropriate thing because it's going to check for the condition before it does anything else. Loop conditions will be simply like take photos until a particular time, which we can set and we are going to set. And then the instructions are going to be, what are we physically telling Nina to do? So let's start with that. So let's operate with the assumption we're using a one-shot color camera to begin with. Over here, and I'm not going to spend a ton of time explaining what each one of these are because the only one that really matters for this particular example is going to be the smart exposure. Now, based off of our simple sequencer, you can recall that we put in how many photos we want, how much time we want each exposure to be, what type of file it's going to be, whether it be light, flat, dark, spy, so on and so forth. We set our camera gain, our offset, and what filter we want to use, and then how often to dither. This particular smart exposure instruction is identical to utilizing the simple sequencer. But if you remember, the simple sequencer requires you to rebuild your plan every single time you set up a new target. With this, we can create a blank template and save it. So that way, whenever we actually go ahead and pick a new target, we can pull forward all of this predetermined criteria. How many photos we want, what filter we want to use. It all defaults in if we save it as a template. So we will go over that as well. But let's start with the assumption that we want to take just one photo. And let's say it's 300 seconds long. We're gonna leave these as default. The reason why it's in parentheses and it says camera and parentheses camera again is because when we actually go back to our options what our equipment, and then we connect our camera, we can actually say what we want our default camera gain and offset to be. For the ZWO ASI 2600mm Pro, I always use a gain of 100 and an offset of 30, and that's just as true for LRGB imaging as well as SHO imaging. I don't personally like to change it just because the noise factor, when you look at all the diagrams for that particular camera, 100 by 30 seems to be my best option. So what we're going to do is read this. We're going to take one photo that's 300 seconds long. It's a light file. It's going to bin one by one. It'll default to my defined camera and gain and offset. And then the filter, we're going to assume for a one-shot color camera, this is maybe the L Pro or some other light pollution filter. And then we want to dither every image. So what this is going to do is it's going to take one photo. After it takes this photo, we now want to check for something like autofocus if the HFR has increased, or if we change the filters, maybe. And if I come over here to this ellipsis, it will actually give me an option to copy it. So let's say we're shooting a L Pro as well as maybe a L Extreme or L Enhance. We can now set up multiple filters to shoot. And maybe we want to shoot 20 of these and 20 of these. And just real quick side note, the reason why you see a red circle with an exclamation point is because our camera is not actually connected. This is a visual cue that something's not going to work because it is not set up. So in this particular case, I am not using my imaging computer, I am using my desktop, and that's why you see this. And this will come up multiple times whenever we tell an instruction set that requires a piece of equipment that is not connected to do something. So don't worry about that for right now. So if we go back, we can see we're going to shoot a broadband for 20 shots and then hydrogen for 20 additional shots. But we want these to loop until maybe a particular time. We want it to shoot all night and just keep looping that particular set until, let's say, dawn. So we'll go, forgive me, I scrolled too far and too fast. right here, loop until time. I'm going to drag this over, and then I want to point out one thing. When you look over here, see how it says loop to time, and then we have a clock, but then we also have a checkboard. That checkboard means it aligns with loop conditions, which has a checkboard over here. Same thing with triggers, it has a lightning bolt, so only items with a lightning bolt, such as here, can actually be used as a trigger. Let's say we want this to now be nautical dawn. If you recall in the first video, I told you that we want to make sure we have an accurate location. So if I go to, excuse me, I'm going to go to options. And then down here, you're going to see my current location. Once you have defined what your location is, that will automatically populate this nautical dawn. Or maybe you want astronomical dawn, which is going to be almost 40 minutes, I think it was, sooner. But you can pick whatever time you want. Maybe you know this target's going to actually set behind a tree at 2 in the morning. So we'll say time. And this is a 24-hour clock, so if you're going to say like 11 p.m., you'll use 23 as opposed to 11. So let's say at 2 o'clock, we know that this target is actually going to fall under or behind a tree, and we wanted to switch targets at that point. We can definitely define that. For the sake of this video, I'm going to just stick with astronomical dawn. So the way you read this is, we're going to continue to take photos by looping until this time. It will take a photo, it will run all of these commands, it will dither, and then it's going to come back up here and look, do I have any conditions to check for? I have a loop until this time. Is it this time? Nope, take the next photo. And then it will continue to loop that way. It'll take one single photo, and then it's going to come up here and check in the hierarchy of things. What do? Do I keep imaging? Well, because we're not at this time, yes, take your next exposure, and so on and so forth. Our next thing that we might want to consider here is, after every exposure, you might want to check, did the HFR increase by, say, 10%, or did I change filters? I might want to autofocus after each one of those. So the way that we do that is we come up here to Focuser. We're going to check for autofocus after HFR increase. And you can see this has a lightning bolt. Same thing with this triggers over here, so we know we can use this as a trigger. Just click, hold, and drag it and drop it under triggers. And maybe I only want this to be 10%. We only want drastic things. Now again, you can see the exclamation came up because we don't have an actual focuser connected at this time. The other thing that we might want to do is focus after a filter change. Well, here we go. Autofocus after filter change. So now you might be wondering, what is it we're actually doing? Because there's a million options over here on the side. How do we know what to pick? And the simplest way to do it is just think about everything you're going to do. I am going to create a link here with this video where you can go download just this generic template and you can customize it the way that you would like. To try to help you guys out, I will do that for you. After we do this, how does this read? What it'll do is we're starting in order. It's going to check, do we have an HFR increase? Well, we haven't taken a photo, so it's going to skip. Same thing with filter change, it's going to skip. And then it's going to look, are we at 4:37 in the morning? Nope. Take a photo. After every single photo, it will then bounce back up to the triggers and it will check, did our HFR increase by 10% or more from our last photo? If no, it'll then go to, did you change a filter? No, we did not, because we've only taken one image out of 20. Okay, is it 4:37? Nope, take another photo. And it will continue to loop with that logic until we've hit 4:37 in the morning. Or if we need to run an autofocus, if we see that two images have a greater than 10% difference, it will automatically run the autofocus before taking the next photo. What we can do is we can actually give this a name. And let's say, let's just call this one broadband. And what I'm actually going to do here is I'm going to delete it. And then because we're just going to continuously loop, you can just leave your quantity at 1. It truly doesn't matter because you're going to take a photo and then you're just going to keep looping this order until that time has approached and it starts its shutdown sequence. So with this, we can call this broadband. Now what you can do is you can save this, or we can duplicate it. But maybe for this one, we want to call this narrow band. And then we will go ahead and change what filter we use. So if I do this, let's call this narrowband test, just so I can tell from my own templates which one's which. I can click save, and I can click save. Now, for the sake of demonstrating this, I'm going to delete these. Let's say we came in, we want a clean slate. We can go here to templates, and then I can come down here and find my narrowband test as well as my broadband test. And these are all of my personal templates that I have created for myself. Nina does give you some basic ones, but sometimes I think it's easier just to go ahead and set it up your own way your first time. That way you kind of know what you're looking for. You can utilize those, of course, for either guidance or because you like what they have. But I want to make sure that you understand what it is we're doing. We're building that Excel formula from the inside out, effectively, is what we're doing. But you can see here, right? If we created a target today and then in 2 weeks we do another target, these templates are already built for us. We don't have to do anything additional. This is not everything, of course. So this is just going to be our instruction set for what do we want the camera and focuser to effectively do. We obviously need to add some more instructions, but what I'm going to do is I'm actually going to create a new target set. So I'm going to minimize this. I'm going to come over here to this instruction set, and I'm going to pick an object sequence, and I'm going to click hold, and I'm going to drag that, and I'm going to make sure that red line is above my current box there. Now, one of the nice things is because we can build this in pieces, watch this. I can click anywhere in this bar and drag it inside the instructions. If you look on the right-hand side, add instructions here, drop it, and look at that. Now I can build out a target with these instructions included in it. The nice thing with this advanced sequencer is we can drag and drop, and we can truly customize this the way we want. So if we think about what other instructions might we need this to do before we actually start imaging, well, for me, with monochrome, I might want to switch my filter, but in this case for one-shot color, we're going to assume that we're already on the filter we want. So we might do this. Let's go down to our focuser, and let's say we want to run an autofocus routine before we start anything. We want to make sure it's in focus so we can accurately plate solve. So I just click, hold, drag, and drop. And again, just it's not connected, nothing to worry about. So how this will read is it will look for the target, which we don't have one defined yet. It will then run an autofocus routine, and then it will start checking these items. Did we hit this loop condition? And if not, it will start to image. But we might want to do something else before we get to that point. How about a slew and center, right? We need to get plate solving. We need to actually find our target before we start doing anything. So we're going to come down here to the telescope. We're going to slew and center. I personally like to run an autofocus before I do this because if your stars are so out of focus that it can't accurately plate solve, you're going to be spending time autofocusing anyways. So I personally like to just go ahead and do it just from the beginning, and then you actually don't have to run another autofocus. You're already ready to go. So after we've slewed and centered, we probably want tracking to start. So if I go to guiding, which is going to be up here, let's say start guiding. And let's put that after our slew and center. Now, one of the nice things that I truly love about this advanced sequencer is the ability to force a calibration. I can turn that on. And then, obviously, it's going to force a calibration. Many of you, such as myself, set your telescopes up night after night, but you take them back in morning after morning. Well, you have to repull or align. You have to re-force a calibration to ensure you truly have the most accurate calibration for tracking. So we can actually force it now on its own without having to go into PhD2, hold the shift button, and then click the little guider button to force it. We can now tell Nina to do that for us. I personally love this option. So now we have some other check criteria that we will likely want to put into place. And you can see here inside of our imaging target package, we have triggers of check for autofocus criteria. If the HFR increases or if we change filter. Now, if we're shooting with one-shot color and we're only going to use that one filter, we probably don't even need that one. So we can just do if our HFR increases. But what about meridian flip? How do we check for potential issues with tracking? which you can do now with this advanced sequencer, and that's amazing. It is truly a game changer. So you have triggers down here, but I personally like putting those criteria in this triggers. So the reason why you have multiple is because anything that's under this trigger will apply to anything below it. And you can see this outline here of the box that goes down here. This is our target set or object sequence set. Any trigger that's set here will automatically be propagated down to every single action or instruction thereafter. However, this instruction will not go in reverse order and be propagated up here. It only works from top to bottom. So this autofocus will only apply to anything inside of this target set here, or this imaging sequential order set here. This trigger will apply to everything, and that might come in handy if we have a narrowband target as well as a broadband target set under here. If I come back over to my templates and I do narrowband and I can put it here, so now I don't have to put check for meridian flip inside of this triggers and then put it inside of this triggers. I can actually put it inside of this one and it's automatically propagated down to both. So the way that will look, and let's go ahead and take a peek at that, meridian flip. If I put it here under triggers, so what it's going to do, and let's read this just to make sure we're all on the same page. And again, the telescope mount is not connected, and that's why this popped up. What it will do and how this reads is, what's our target? Have we passed the meridian flip time? If no, then run autofocus, then slew and center, then start guiding with forced calibration, then has our HFR increased by 10%? No, we haven't taken any images, so has it hit 4:37 in the morning? No, take a photo. After it takes this photo, it will then go all the way back up here and it will check, are we at the meridian flip time? No. It will not redo these because once these instructions have completed, they're done. It's as if they no longer exist because they've already run. It will skip through this instruction set and it will go to the next trigger, which is, did our HFR increase? No. Are we at 4:37? Nope. Take another photo. It will jump back up, meridian flip, HFR increase, loop time. So again, once an instruction has run, it's done. In this case, we have an instruction set which will continuously loop until this time. And that's the only reason why it continues to take photos is because we put it in this set. We will continue to loop it. And we will be able to image all night uninterrupted because we put it in this broadband test set. Again, let's say we wanted to go at 1:37 in the morning. We want it to stop shooting the broadband. And now we wanted to shoot the narrowband. Well, did our HFR increase? Nope. Did we change a filter? Yep. So it's going to run autofocus. Then we're going to loop till nautical dawn. Then we're going to start taking photos. Then we're going to jump back up. Are we at the meridian flip through this target? Nope. It'll skip to the next trigger. HFR increase, filter change, until time, take a photo. And it just continues to loop. And now I keep repeating that because it is important. You need to know how this is going to behave, because last thing you want to do is put something in the correct spot and it doesn't keep taking photos. It shuts down at 10:30 at night and maybe you've already gone to bed, or let's say midnight. That's probably a little more realistic. So now Nina has some new functionality with it, and I say new because I haven't been using the advanced sequencer for super long, but for me it is still new, and I think it's worth every opportunity to start using the advanced sequencer. How many of you have actually started to image, clouds have come in and ruined your guiding? You've gone adrift, your guide star moved, but PhD2 starts tracking a different star that's in the wrong area of the sky, and you start taking images of an area that's 40 arc minutes away from where you actually want to be. I mean, it's substantial enough, it's truly going to ruin your imaging, and your target is not even going to be in the frame. You might just be taking photos of stars. Nina now has some functionality that will allow us to check our tracking, as well as check, are we still pointed at our designated target? So the first one here we're going to look at is if we look under telescope, center after a drift. A trigger to initiate a recentering after plate solving determines the telescope has drifted too far from the target. We are going to add that to our triggers. So for my particular telescope setup, if I move more than 517 pixels away in the background, plate solving will evaluate that, and then it will recenter by slewing, plate solving, and making sure that I'm back to where I need to be if I've drifted. Now, I wouldn't necessarily run this after every single exposure, but let's say we do every 3 exposures. The way this will read: our target, check for meridian flip. Have we drifted after 3 photos too far away from our target? Well, let's assume everything else has been running. Let's say we're on image number 13, just completed. And now it's going to plate solve the image you just took. And it's going to evaluate, have you moved more than 10 arc minutes, which is going to be the equivalent of 517 pixels away from your designated target? If so, stop everything, slew, recenter via plate solving until it's centered back up in right where you have designated it to be. Once it's done, it will then jump back down. Has the HFR increased? No. What time are we looping until this time? Take another photo. After the next series of 3 photos, it will check, have you drifted again? Nope. Take the next photo then. If you drifted, it will automatically recenter, and I don't know how many times this could have possibly saved me. I've had numerous times where clouds came in, my guide star was lost, and my tracking wasn't as accurate as I would have hoped, and therefore I start imaging something that's nowhere near where my target was designated to be. The next trigger that I like to include in here is if I come on down, I think I'm going to go to guider, and we're going to say restore guiding. So if for any reason your guiding was interrupted, maybe you lost your star and PhD2 couldn't get it to start, but it went ahead and started imaging your next exposure, and you look and you have terrible star trails. It will try to restore itself after every single exposure now, because we're telling it to check, is guiding going? If not, started. But after every 3 images, have we drifted too far? If so, let's recenter, and then we'll start guiding all over again. It will kind of correct for itself. If you're like me, you're asleep and you're not actively watching every single exposure. This is a lifesaver. It's also a data saver, right? If I start imaging something that's not even in my field of view, I'm going to have to throw all of that data away. So this has the ability to save an entire night's worth of data. This might be all I want to do for one-shot color camera. And let's delete this here, which was the narrowband test section that I created. And let's say we're happy with this. So I can go, let's say DSO test. And now let's save it. So let's say we come in for the first image of the day. We're going to framing. We have our target. We like what we see. We're going to say add target to sequence. And then we can come down here to sequencer. Now, I just named what we created the DSO test. If I click that right here, look at that. It pulled in my target information for me, and it gives me where it's going to actually transit. In this case, it's 37 degrees. Transit to the south from my location. I can see what time it's going to be up during the astronomical dark, and then the nautical dark and dawn are going to be here. Then I already have all of this, right? If you remember the simple sequencer, you have to rebuild your imaging every single time, and you have to guess how many photos am I going to possibly take in a single night until it's too light out. But then you got to remember, every time you dither, it's adding time. So you really don't keep track of that very well. Then we can say nautical dawn as our stop time. It'll automatically stop on its own in this loop condition once we hit this time or go beyond that time, because 5 minutes might actually surpass it. You might be at 4:40, but it's still going to stop once you've hit this time or surpassed it. But every time our meridian flip will be checked. We'll check if we're center drift. It'll restore the guiding if that's the problem. It will then run autofocus as an instruction. We'll slew and center to the target. We'll force calibration with the starting of guiding. We'll check if our HFR increased. We'll check if this time has passed, and if all of those are successful, we'll take another photo and we'll loop it all over again. I'm gonna delete this because we're gonna really quickly just look at a beginning and an end. Okay, so now what we're gonna do is we're going to look at setting up our beginning sequence. It might be unparking the scope, cooling the camera. So what we're going to do here is we're going to pick a sequential order set because I have something in mind that some people might like. If I scroll all the way back to the bottom now, sometimes you set up your telescope, it's already polar aligned, it's ready to go, and all you want to do is wait for it to be dark enough for it to automatically start. You can then come down here to wait for time, put that as an instruction, and we're going to select nautical dusk. So at 9:59 p.m., we will begin imaging automatically. But we needed to cool the camera, we needed to unpark the mount, we needed to turn on our dew heater if your camera has one built into it. We don't want it to all sit there and wait for each other, right? We don't want the camera to take 10 minutes to cool and then unpark the mount and then do any other tasks that you might want. So what we can actually do here is grab a parallel instruction set and drop it right underneath this time. So the way this will read is we're going in order here. So the first thing is I have to wait for this time. Nothing will happen until this time has happened. I want it to cool my camera in parallel with turning on the dew heater, also in parallel with unparking the mount. Say turn that on, and let's just say -5 degrees Celsius. So the way this will read as our beginning instruction is wait for this time and then run all of these commands at the same time because it's a parallel instruction set of cool my camera, turn on my dew heater, and unpark my scope. So what we can do then is call this beginning sequence. And I'm going to call this test just so I know which one this is. So I'm going to say save. And then I can close this. So then what I can do is at the end of the night, we want it to do something similar, right? We might just want the parallel instruction set though, where we might want it to warm our camera, turn off our dew heater, and park our scope. And we don't want to wait 5 minutes or so for it to warm the camera before we then turn off the dew heater and park the scope. We want them to run all at the same time. So now what we can do is say end seek test and save it. So let's close out of here. Let's assume you're coming in for the first time now that you've got your templates set up and you want to shoot the Eagle Nebula this summer. We say add target to sequence. We go to sequencer and we want to say DSO test. It is now going to load our target. It's going to keep all of our saved criteria already that we know works. I'm going to close the box, which will minimize everything because it's easier to read. I'm going to go to my templates and I'm going to go to end sequence test and drag it right below it. You can also put it down here in this end sequence area. That's fine too. And then you want beginning sequence test. We'll throw that up here in this sequence start area. So here's our whole plan. At the beginning, we're going to wait for this time. Once it's hit that time, we'll then run a parallel instruction set of cooling the camera, turning on the dew heater, and unparking the scope. Once all of these have completed in parallel, we'll minimize this. We will then check our target. We'll look to see, these will be checks after our first image, so we'll skip these. We'll come down here. Our first instruction, run autofocus. Then we'll slew and center. Then we'll start the guide and check our calibration by turning it on and doing a new one. Then we'll skip this for now because we're on our first image. We'll check, has this time passed? And maybe we want this to go all the way till nautical dawn. Then take a photo. Once that photo is done, again, we want to look at the global triggers here by coming all the way up here. Have we hit our meridian flip time? Nope. Have we drifted? Nope. Do we need to restore guiding? Nope, it's still running. Then we will jump to the next trigger in this scenario, which is, did our HFR increase? Well, if we just took our first one, we won't know. Has the time passed? Nope. Take a photo, and it will continuously loop in that cycle until our loop condition has been satisfied. Once it has hit 437, this will end everything in this sequence. So if we minimize it, we'll then check our end. Once M16 is done imaging, we will then, in parallel, check and turn off the cooler and warm the camera. You can put, like 4 minutes maybe. We're also at the same time going to turn off the dew heater, and we're also going to park the scope. That way when we come out to check our setup, everything's turned off by the time we're ready to shut it down for the day. So this has been a lot of information. I will upload these and put it as a link inside of the description below. Be sure to check that out. If you have questions, comments, or concerns, feel free to let me know. Put those in the comments below. If you liked what you saw here, help support my new channel by subscribing and pressing the thumbs up. And if you have questions about specific things, I'll be happy to create videos that will meet everybody's needs, because we're all in the same boat. We all started somewhere, and we all seeked help from somebody else. And with that, I bid you clear skies, and we'll see you next time.